Good day, all of you. This is Dr. Masalila, lecture of Phy112. Work, energy, and power. Work. Force applied and the object moves in the direction of the force. And this is what called work done. So examples of work where work is being done. When an object lifted up against the gravitational force, you can see that you are lifting an object against gravitational force. So you are actually work done is whereby a force is causing some certain movement. When an object is dragged along a rough surface, you can see that you are dragging an object. It means the work is being done. Force to drag the object does positive work. Now there is negative and positive work done. So let's continue. Frictional force does what you call a negative work. The sign of the work depends on the direction of the force relative to the displacement. So for you to prefix the sign of the work, you need to now study the direction and also the relativeness of that direction towards the displacement. Work is done even if object moves with a constant velocity. What for you to say work is done? Velocity, magnitude does not matter. What matters is that force causing a certain distance. If yes, it means that the work is being done. So what is work done? Work done is force times displacement. Let's take an example of that diagram there. You can see that the force is moving that diagram from that solid form to the dotted. Example, work is done when you are lifting, let me say you are lifting a chair from point A to point B. You see that there is displacement there and you use the force there. Whether you are lifting, whether you are pushing, but that's work is done. So in dimensional analysis, we say that for us to find dimensions of work, we need to know that work done is equal to what? Force times displacement. And what are the dimensions of force and what are the dimensions of displacement? Therefore, the dimensions of work are m L2 T negative 2. And you know that from the dimensions you can find what? You can find the units. What are the units of m? M is mass. What are the units of mass? It's kg. L2 is length squared. Length squared is meter squared because the units of length are meters. And T negative 2 is second negative squared because the units of time are what? Are seconds. But we can say that pseudo units of work is Newton meter or 1 joule, or we can say 1 joule. So sometimes work, the force acting can act at an angle. So when the force is acting at an angle, according to the vector principle, we need to know that we find the x-axis of an angle, the x-axis of a force, and also we find the what? We find the what do you call the x-axis of a force, and also we can find this x-axis of a force, which I'm writing x-axis of a force. Then also we can find the y-axis of a force. So for us to say that the work is being done. So from that diagram there, we can see that. So for work done here is going to be what? Work done according to this diagram there. Work done is going to be what? Work is going to be what? F times S. S is for what? Is for the distance. But work done according to the diagram there is going to be what is the force acting there? The force acting there is what? We are going to find the force acting there, and because this force is acting at an angle theta, you are going to do what? You are going to separate the x components of the force and also the y component of the force. X component of the force and also the y component of the force. Consecutive and non-consecutive forces. We have consecutive and non-consecutive what? Forces. Consecutive forces. Work done is independent of the path taken. The work done is going to be independent of the path taken. Work done on a closed path is 0. That force is what you call the gravitational force. Is the gravitational force. So the gravitational force is independent of the path taken. Is the force which is acting what? Downwards always. So we have what you call the non-consecutive forces. Work done is dependent on the path. Like the work done is going to take into account of the path which is going to follow. Work done on a closed path is not equal to what? Is not equal to 0. It's not equal to 0. Example of this force is friction. You know that friction, you are going to make sure that you take into account of friction when you calculate. So non-consecutive forces cause change in mechanical energy. So let us now go to power. Go to power. So now we are just doing what you call definitions. Go to power. So what is power? What is power? What is power? Power is the rate at which work is what? Done. That's power. The rate at which work is done is power. So power is equal to W over T. And we need to know that now the unit of power is what? Is kg meters squared second squared second this. Then you solve this, then that will be the units of power. So from dimensional analysis, so the exercise which I'm going to give you is use dimensional analysis to find the dimensions of what? Find dimensions of power. Use dimensional analysis to find dimensions of what? Of power. Find dimensions of power. So an example, we have an example there. A crane lift 1000 kg steel beam to a height of 50 meters in 70 seconds. Calculate the work done and the power there. So work done against the gravity F should be slightly mg or that. So the force acting there is what? Is going to be F is equal to mg, which is 9.8 this, which is 9.8 that. So what is the work done? What did we say? We said that for you to calculate the work done, you are going to need the force times the distance. And from the question there, it states that the crane lift a 1000 kg of steel beam at a height of 50 meters in 70 seconds. Now, what is the given data? Yes, we have times 50, which is the distance. So what is the force? The force is the same as the weight. Therefore, weight is equals to mg, which is what? Our mass there is what? Is 1000 times, what is our g? Our g is 9.8. Therefore, you say 1, 2, 3. So our force there is going to be 9,8 800 times 50. You first calculate this force, and this force is the same as our what? Is the same as our weight. Mind you, this W here is work done. So now you can see that our work done is going to be 9,800 times 50. Then our work done is going to be what? It's going to be 490,000, which we divide by 1,000 for us to convert from joules to kilojoules. We know that if you have joules, when are given joules, what do? You just divide this by 1,000. Divide this 490,000 by 1,000. So you have this kilojoules. But if the question does not specify for you to leave your answer in joules or kilojoules, you just leave your answer in joules. So, mind you, we are supposed to find the power there. The power is equal to work done over time. So, what we are going to do is we are going to say, what is our work done? Power is work done over time. So, what is our work done? Our work done is 490,000. So, we're going to divide by how many seconds? 70 seconds. And our answer there is going to be the work done. It's going to be the work done. And what is the work done there? The work done is going to be 7,000 watts. So you can take it to what? You can take it to kilowatts, which is 7 kilowatts. Because for us to convert from 7,000 there, we just divide by 1,000 for us to get 7 kilowatts. So we have another example there. Which you need to more. A horizontal force of 5 Newton is needed to maintain the velocity of 2 meters per second for a block of mass 10 kg sliding over a rough substance. How much work is done in a minute? So you need to understand. These are the principles that you are going to understand. So, this our given data there, we are given that, okay, the question says you need to find work. Work is equals to force times distance. Now, are we given force? Yes, we are given force, which is 5 times. Now we need to find the distance. And for us to find the distance, we need to know that according to the equation of motion, we are saying that speed is equal to distance over time. It's equal to distance over time. That's our speed. It's equal to distance over time. And our distance, which is s, is equal to what? It's equal to speed times time. Our speed is 2. They say that in a minute means what? 60 what? Seconds. So our distance is going to be 2 times 60, which is 120 what? Meters. Then we're going to say work is force times what? Force times distance, which is our force is force times 120, which is going to be 600 joules, or what? Or divide by 1,000 to get to what? To kilojoules. The work is done against what? Friction, because we say that it's sliding. We say that it is sliding over a rough surface. It's sliding over a rough surface. Let's go to another example. Now we go to this lecture, introduction of lecture of what? Of energy. What is energy? What is energy? We say that energy is the ability or the capacity of a body to do work. The work which we are talking about in the previous chapter, the ability to conduct it or to do it now is energy. So You have kinetic energy, potential, chemical, and nuclear energy. Kinetic energy is the energy of the body when it is what? Moving. Potential energy or potential, we have different types of potential energy. Gravitational potential energy, GPE. Chemical potential energy, which is stored as chemical energy, or sometimes we have the nuclear energy. According to Albert Einstein, E is equals to mc squared. So we have also the thermal energy, and also have the electrical energy. So we are going to deal with mechanical and kinetic energy and potential energy, kinetic potential energy in these chapters. Before we can end our lecture, let's go to this following slide. When work is done on an object, its energy will change such that the work done object is equal to the change in the energy of the object. When we do the work now, the energy will change that the work done of the object equals to the change in the energy of the object. Let me show you example here. Let me try to illustrate. Guys, you forgive me. My phone which I'm recording using is give me trouble. I'm not used to this technology. Now, let's take an example of a diagram like this. When something have a GPE, let me say here over we have a GPE. GPE is going to be reduced to what? To kinetic energy. Like, energy cannot be destroyed or created. It can only be transformed from one form to another, but total energy of the system is unchanged. When let us assume this is a closed system, and you start with a 500 kilojoules of energy. Although GPA is going to change to kinetic energy, actually, we are not losing energy actually. The energy is just what? It's just changing from one form to another. So, kind of physics, it needs you to be doing examples, but as you in class, we are going to conduct such examples so that you can understand what we are talking about better. What we need to get in this slide is that energy is being converted from one form to another. It is not changing. We just convert it to one form, from form A to form B to form C and to form D.